All right, folks, let's get an overview of this project on autonomous material transportation for intralogistics. And so our goal here is to have a very hands-on project where we are going to have a analysis and boots on the ground to develop a market development strategy for this specific kind of market segment for running autonomous vehicles in this operation domain of intralogistics. While you have heard of, warehouses and automation in warehouses, that's largely focused on inbound logistics and outbound logistics. In intra-logistics, essentially, we are talking about production facilities, manufacturing plants, where you have intermediate products that need to be transported from one portion of a very large space in this production area, which could be, from anywhere from 2 miles to 6 miles away. And these are very large, from 12 acres to 1,200 acre facilities that are producing, say, chemicals like methane gas, or automotive systems where you have many subsystems that need to come into an assembly shed and be coordinated. And also, for example, in consumer goods like manufacturing refrigerators or vending machines, and where you have intermediate products that now need to be moved from one plant building to another facility within the same, physical landscape. But the goal here is that we need to have these vehicles are essentially operating indoors and outdoors. They need to operate 24/7, and they need to operate in bad weather conditions too. So let's take an example. Say you have like a methane gas processing plant, and here you're basically now synthesizing and refining, some petroleum byproducts, and every day, at least 30 times, you need to sample the intermediate products that are being produced in plant facility building 1, building 2, building 3. And we need to take these samples 30 times a day to the testing facility that is about 1.5 miles away. And we need to have essentially this vehicle that goes to each production building, picks up a barrel, and then takes it to the testing facility, collects the barrels, and repeats this 30 times a day. Today, this is done manually, right? And so the goal for this kind of intralogistics autonomous material transportation vehicles is to now automate this process as a fleet and be able to do that. Fine, that gives us a setting, but what are we trying to do over here? We need to essentially focus on 3 aspects in this project. One is talk to the potential customers, people who like the plant facility owners, and see where they see value addition in this kind of system. Is it in the safety, in the precision, in the extended operating hours, in the streamlined workflow? And how can this actually be a useful system, not just as a single or 2 units in a facility, but can the whole facility then start to adopt this, right? So customer discovery is the first phase. The second phase then is going on to understanding how do we enter this market, right? What are the different type of aspects that are specific to this market in terms of, after we've understood the customer needs, that how do we deploy in this market? What kind of game plan? Are we a service vendor? Are we an operator? Are these vehicles leased? And then who does, and the actual deployment? Who does the integration of this? How do we come up with a business model for that? And then third, which is a very exciting part of this project, is to actually have boots on the ground and go to pilot facilities. So let's get started. So here are some pictures where you see these vehicles operating indoors, outdoors, nighttime. And they need to operate, they need to essentially be able to tug up to 1.5 tons or 1,500 kilograms of payload. And they need to be able to now detect people, bicyclists, vehicles. But note that this is much simpler sort of operating domain than driving on a street where you have other vehicles and a lot of clutter. This is all private property, right? So this is anywhere from 6-acre to 1,200-acre, production facility. And they need to be able to go on rough roads, on inclines and slopes, and to operate in night and in rain. And they need to have some kind of charging facility. And of course, be safe, right? Follow the traffic rules, avoid crashing into people or goods or other vehicles, and be able to do that reliably 24/7 like that, right? And essentially, we want this to be a fleet operation system that is operating in this closed space. So let's take a quick look at the competition, right? So this is a very emergent and very crowded area now, which is in the indoor, warehouse automation with forklifts, with tugs, with goods to person systems, where you have many companies. Raymond is, over, several decades, over 50 years old. It's part of Toyota. And then Seegrid, which is based in Pittsburgh, and also has some folks working on it in Philadelphia. They've developed what are called automated, they've gone from automated guided vehicles, which just follow the line and you need to, say, put a magnetic strip on the line, which was the first generation, to autonomous mobile robots, or AMRs. And here you have LiDARs, cameras, and they have fitted these vehicles out with a lot of sensors to make them intelligent and to do their navigation on their own, but in a structured indoor space. And their work is very structured. They know where they can drive and not drive, and they have a very well-defined, map of that space. Then you have like the Amazon Kiva kind of robots within the warehouse that go and lift up pallets or lift up containers and bring them to like the picker or the fulfillment person. And there are several of these in this space, and they operate in, again, a very regimented and well-defined operation zone. Then you have like construction, mining, or cargo automated systems that are much more in rough and tough outdoor, but they cannot work indoor. And so the golden place where this project lies is, being able to navigate indoors and outdoors, and being able to navigate in and around people in a less structured space. Essentially, we are not changing the infrastructure to make a room for this. And so there are technology aspects that are very interesting. And so, for example, there's this concept of software-defined vehicles, where software is basically used in designing you can do the design, the development, the testing, the deployment in the cloud, because now these vehicles are electric vehicle chassis, so much more simplified than an internal combustion engine gas guzzling vehicle. And they essentially have, like, say, one or two main computers that connect to these different types of sensors. And one of the aspects in the project you'll have to figure out is, okay, well, what is the mix of sensors that these facilities need? Why do they need them? If we have more of these, what does it enable? And so on, right? So, but with software-defined vehicles, you can then do updates, you can do fleet management, you know essentially the status of your entire fleet at all times. You can even take over control and do teleoperation. And so this is something that is essential in this type of market. And there are many sort of core capabilities in these vehicles, like high precision drive-by-wire control, so that we can then interface it to a computer and then manage it. And then there are CAN bus, open CAN bus interfaces. This is for steering, for throttle, for braking. All of that communication happens in a very organized manner. You also want to have very standardized chassis if you use, and so that you can change it for different types of payloads. We're not fixed on, that this vehicle should always look like some sort of a cart, but we could change how the cart actually looks depending on what kind of work it's trying to do. There can be multiple steering modes. It can be two-wheel, front wheel, rear wheel, all-wheel steering for better traction, for tighter turning angles. It's software defined, as I mentioned. That means that you have a live access to the whole system. You can update the system remotely, and you are operating this fleet via the cloud. And it has to be safe and also Generally speaking, we will be following, like, we'll be using AutoWare as a software in all of these deployments, but you don't have to worry about that. It's an open source autonomous vehicle stack. I'm just giving you the technology that might be behind it. If all of these don't make sense, we're just trying to get an overview at this point. We're not trying to dive into the details and understand every little bit of it. The first step of your project will require you to actually do something that's very interesting, is customer discovery. Understand where the value is in this process, but from the customer's perspective. Ask them the right questions, understand what their operating conditions are, what their needs are, what their opinions are, and whether there is any value in this, if at all. And 24/7 operation, increased safety, better precision, more agile workflow in terms of changing routes. So what kind of payloads are they moving, and how do they think about this in terms of risk? So you would start to develop first, a problem hypothesis to know what the problem is each customer has, and whether this product, and build a product hypothesis to see whether this addresses that problem. And then you want to have a follow-on conversation, and we would like to get to about 30 different customers, and we'll be able to help assist you with getting interfaced with these customers to begin with. But then you would hit the ground running from that point onwards. In terms of these customers, we'll also want to know about companies that are producing these systems, and how they are navigating so the competition, so to speak, but not necessarily direct competition also. We'll also want to see, like, companies that did try to adopt something like this, but it didn't work out. So we are keeping a pretty open mind in terms of the customer discovery. Once you have the customer discovery, or as you're building it up, I should say, because customer discovery will take some time, you then want to start to develop, figure out a market development strategy. What is the initial market? What is the entry strategy? What kind of company should be operating in this space? How should we have, integration of, sensors, of different kind of containers for the payloads, and also being able to ship the vehicles to the destination? What kind of partners are needed? Who develops the chassis, and how do we come up with an integrated system with retrofits for this kind of automation? And then once this system is deployed, you need to figure out, okay, what is the service and support provider strategy also over here, as in terms of execution. So this is a kind of grid to guide you through that. And finally, you can think of this project as, step 1 and 2 are more in terms of analysis and really understanding, by picking up the phone, talking to people, really understanding the market through market research. There are not too many market research reports, in this indoor-outdoor intralogistics space. So we are really interested in this kind of primary research. But we also want you to have boots on the ground in terms of assisting in pilot deployment, customer deployments, and we'll work with our customer, the teams, to have deployments, for example, in Yamaha, a manufacturing facility in Georgia, or Siemens manufacturing facility in Ohio, and we'll provide more information as these are scheduled. But we'd want you to have these boots on the ground and actually see the initial deployment, talk to the customers in terms of what they expect to benefit from, and see how this is actually executed, right? Because the devil is in the details and is in really this face-to-face interaction. Our overall system here is, there are many partners involved that can be involved, I would say, but mainly we are focusing on Eve Autonomy is one main partner, and that's a joint venture between Tier 4, which is a Japanese open source autonomous driving software company. Tier 4 is funded over $300 million in venture funding. And Eve Autonomy's other backer is Yamaha, which is a 51%, has a 51% stake, and Eve Autonomy is developing this technology. So let's take a closer look now at what Eve Autonomy is offering. And I'm just going to spend another 5 minutes or so just to give you a glimpse. You'll have access to all these slides. So Eve Autonomy started with this, Yamaha go-kart, this not go-kart, just a car, electric vehicle kart facility. It has a LiDAR on the top. It has 3 LiDARs in the front. And essentially you can see this is an example of, the cart driving through indoor and outdoor parts of any different facilities. They have deployments in over 27 different facilities with about 33 vehicles in operation last I knew from them. So this is just showing you that this cart also has to come indoors, and it's basically dropping stuff off. And this is a repeated run. It has to continuously do this with, and be working between buildings like that, right? So has to be able to tug, like I mentioned, 1,500 kilograms, and be able to drive this for at least 50 to 65 kilometers on one charge, like that, right? Being able to tug that amount of payload and operate in different weather conditions. The key part here is, this intralogistics vehicle needs to operate without any special construction or infrastructure. It should be ready to just integrate within the facility and drive like a regular vehicle, but with the added safety provided by the sensing system. Has to, again, be able to navigate through these indoor cluttered spaces. And outdoor can be very sparse, and sometimes it's very difficult to localize where it is. But it has to, there are several challenges in doing that. And also there could be initially routes to go from, say, building A, B, C to a testing facility. And then they might want to, the facility operators might want to change the route, and we should be able to update the routes, or the user should be able to update the routes like that, right? The benefit here is it's all these will be operating on private property, so the liability is restricted. And generally, Eve Autonomy, leases these vehicles in autonomy as a service mode of about $2,800 per vehicle per month. And we need to see whether that, that model is good. How does that work in the US market? And again, it has to operate in different operation conditions. These are just some specs of the vehicle. And then it has to be able to work, by when you deploy this, essentially the sensors, which are these LiDARs or laser rangefinders, they essentially send laser beams across, and they basically can create a map of the world. So once you manually drive this around, you generate this map. And then after that, you need to now take that map and label it and say, okay, this is where you can drive, this is where you can't drive. And then you use that map. And essentially what this vehicle is doing is, again, using its laser to then say, okay, now I know where I am on this previously generated map. But there is some effort that, what the sensors just return is what is called a point cloud map. And that's just like a lot of, data points in terms of where the lasers are. And then we need to semantically outline, okay, this is the lane that we need to drive on. Here is a stop line. And then here is where we need to slow down because there could be traffic coming on the other end, and sort of implement these kind of behavioral rules. And there are tools that are developed, again, with Tier 4, with AutoWare, to take these maps and then to start to label them. And basically now, and this is the manual portion in the first part of the deployment. Ideally, this deployment would take about 3 days once the vehicle is there, manually driven around and mapped the location. Here's an example of a petrochemical plant, where it's, conveying this resin samples as a 1 mile outdoor route over here in one lap, and it has to do this, 30 to 40 times a day. And this, the impact is a reduction of 1,800 hours per year in terms of manual driving working effort. You can see this is the route it has to go along, and then makes a loop back and has to do this 30, 40 times a day, every day, right? So, and it should have remote departure functions, from web apps, and be able to cooperate with any kind of lights or alarms that the facility has in terms of go, no go, or production is active. There's another use case of an assembly plant with Panasonic Corporation. and where they're making large fridges and beverage dispensers, and this includes transporting, essentially replacing forklifts and trucks that are humanly operated, and transporting these intermediate products, like say just the enclosures or the doors of these kind of large fridges from one building to another. And similar benefits over here of being able to minimize the risk and the safety and improve the safety while transportation. And then there are other examples of large facilities like the Yamaha Corporation, an assembly plant, and essentially there's it has 8 buildings, but you have to go over bumps and gratings, and you can see again the driving space is quite busy over here, quite cluttered. Has to be able to navigate that without a hitch. And so here you can see an example of how this system is now driving around, and essentially it goes from one building to another. They load on the payload, and then the worker at that point says, okay, now you can go. Just hits a button and says go, and it follows this fixed route and keeps repeating. So no rocket science over there. It has to be a very intuitive, simple system, but it just has to work very reliably and provide the benefits that are promised with this kind of technology. Essentially, we're taking the autonomous driving technology and moving it from driving on the streets to driving, within these sort of more closed systems where the risk is much more limited, the complexity is much more limited, and we need to identify what is the product market fit over here, what is, the bottom line that we need to be able to operate above, and how do we start to enter this market over here. So I'll stop at this point, and then, we'll obviously take all of our discussions online. I'd be happy to work with you guys and to make this project a big success. Thank you so much.